Hello, ladies and gentlemen, and I hope this finds you well. This is Dr. Skinner here, and welcome to our very last class in the SDLC for the SAD course, Maintaining Information Systems. Let's just very quickly pause and just think back to how far we've come throughout the whole semester, going through each of the different planning, analysis, design, and implementation phases, and everything gone before. And now, at the very end, we think about maintaining the information system. What are our learning objectives for today? Well, look at success factors in system implementation. Yes, I'm just going to take a little step back and just talk about some of the success factors in implementation. I know we're now moving on to maintenance, but I think it's just very important that we contextualize this and think about, well, what are the common factors that say we've done a successful implementation, and what are some of the other factors that we just need to be aware of? We're going to talk about system security as well, because it ties into the relationship between implementation and maintenance as well. We're going to look at 4 different types of maintenance. So some of the different approaches to maintenance: are we correcting problems? We're putting in making our environment more performant. We're putting in new features, and so on and so forth. We're going to talk about some of the cost of maintaining an information system, and then some of the main management issues to conclude with. Okay, so let's crack on, start with implementation success factors. I just want to take the step back to last class on implementation. So conventional wisdom has it that management support and user involvement are at least 2 conditions necessary for an implementation of a new information systems to be successful. But the thing is, right, so with management support and lots of user involvement, even after those 2 things, we still have information systems implementations that fail. It kind of suggests that there must be other factors that influence success from an implementation perspective. And here we have 4 other factors that have been researched, and which we think are, as academics, we think are still important, and we need to discuss about them in classes on SAD. Let's very briefly look at these 4, beginning with commitment to the project. What do we mean by commitment to the project? What we mean is managing the systems development project so that the problem being solved by the project is very well understood, and that the system being developed to deal with the problem actually solves it. Okay, so we're actually committed to understanding the problem that the system's trying to fix and making sure that the actual developed system does actually fix it. So that's what we mean by commitment to project. Commitment to change is quite more difficult. It's tough. Commitment to change, by that we mean by being willing to change our behaviors, being willing to change our procedures, being willing to change other aspects within the organization. So change is hard. Trying to make change, not just from an information systems, but within ourselves as users and system and analysts and administrators and so on and so forth, it's challenging. So if we can be committed to making the necessary changes, then that's a big step forward as well. What else we have? Project definition and planning. This is a measure of how well the project has been planned. Okay, well, if you've done the SDLC correctly and you've been in Professor Skinner's class and you've really focused on planning and you've prioritized your projects, you've gone through everything that you should do, then hopefully the project definition and planning is well defined. And then the last success factor is users' expectations. So the more realistic user expectations of the new system's capabilities, the more likely the user community are going to be satisfied with the new system. Okay, so you've got to set expectations up front that are realistic. You don't want to just leave your sales guys to sell to your user community what a wonderful job this is going to be and get them to buy in, and you deliver it and it all goes well, and then you fall flat because you're not meeting those preset expectations. So it's all about realistically setting the user community's expectations of the new system's capabilities. Okay, so other success we need to think about when determining success from an implementation perspective. Well, the 2 most common and trusted ways to determine if an implementation has been successful is, number 1, the extent to which a system is used, And number two, the user satisfaction with the system, right? So the extent it's used and the user satisfaction with the system. There are 6 factors that influence the extent to which a system is used. So you can see use here in the right-hand red circle. You see those 6 factors around the outside? Management support, system characteristics, performance, satisfaction, organizational support, and user demographics. Let's look at these in a little bit more detail. Well, we've talked about management support already. Let's begin with the user's personal stake. How relevant the system is to the user. All right, so how relevant is it? Is it doing everything that the user wants it to do? Is it relevant to the user's needs? Number two, systems characteristics up above. The ease of use and the reliability and the relevance of the system to its use. Number three, down below, user demographics. What's the age, the degree of computer experience, and other issues and other characteristics of our user community? Okay, if we have an understanding of that, that will define the extent to which a system is used. Number four, organizational support. Support we talked about last week, the extent of support from the organization overall for your information system. Number five, performance. What individuals can do with the system to support their work. Does the system give them what they need in order for them to achieve a high level of performance? That makes sense. And then number six, satisfaction. How satisfied with the system is the user community? So if you have these factors well understood, then you're probably going to have a greater chance of being successful in implementing your new system than if you don't. One thing that's not there that we haven't really touched on is security. And I think we need to touch on it because it is important, security issues when it comes to new systems. And we kind of talked about security in the context of reputation beforehand. So security is becoming more and more important, all right? And when bad things happen, when security is breached, the chances are you're never going to hear about it in the press, okay? You don't want to, because you don't want to get a reputation for not being able to control the security of your environment, the information system, right? So it kind of ties back into the most important factor that you can have for an organization is your reputation, okay? What's it say? $3.86 million average cost of a data breach. That's kind of scary, right? That's a lot for an average cost of a data breach. So we think about that. You think about the fact that you hear so few details from the press about data breaches, you can understand why security is becoming a more and more important factor when implementing a new information system. Okay, so what are the main sources of security threats to an to an organization? And we can break these down to both internal and external. From an external perspective, what are our sources? Theft of devices, unauthorized access, so your firewalls are not configured successfully. A denial of service, DOS attacks. You may have heard of denial of service. This is where bad people outside hack into, say, a library or a classroom, and they take over PCs, many hundreds of them, and they create zombie PCs or zombie desktops, and they attack a server with many millions and millions of requests and knock the server over. It cannot handle all the requests of its capabilities and crashes. So, but denying service through overloading, a server is unable to perform what it needs to do to its user community. We also have malicious software. So we have Trojan horses, worms, viruses. You may have heard some of these. Trojan horse appears to be something normal, a normal file or a normal program on the outside, but it actually contains an unpleasant payload, so that when you open it or when you execute it, it does something bad to your system. Worms and viruses are similar. Worms, they are like and viruses. They both essentially contain a payload which propagate across either by you sending it or by doing it themselves. These again have bad code. They can stop system functionality and similar. The external, so insider, this is scary. So user communities, the user community, and it's the pissed off organizational employee is the biggest threat to your security. It's not external, It's internal. When we do the admin course, we talk about, in chapter 10, the very last chapter in the admin course, we talk about this specifically for a whole class. And it's basically that the employee who's had a career there, who's risen so far, but is not getting the promotion or the bonuses that he or she wants, and they're disgruntled, and they therefore decide to do something against the organization. So the users are actually the source, one of the biggest sources of abuse of a system. Given all that, you need to make sure that you have enough security in there, internal, so that people can only do what they need to do and have access to what they need to have access to within the organization. No more, no less. You don't give anybody any more access or escalation of information or privilege than they need for them to do their job. So the question becomes, how can I make my environment more secure? Well, we can talk about to the external world. We can put in firewalls, these programs, these walls that protect the network from users outside of the network, outside of the organization. We can put anti-spyware software in there, intrusion detection systems. We can put biometric systems in there as well. 93% of firms have firewalls. I'm surprised not 100% of firms use firewalls. When I saw that, I was kind of like, really? Only 93? I would have thought it would just be the de facto standard, but there you go. Right, what else? Let's see some stats on IT security. Some of these stats are a bit scary. I point you down to the bottom left, the top 3 insider sources of security incidents 2014. There you can see it. Current employees and former employees. 65%, 2/3 are from pissed off employees who just want to take it out in an information system because they haven't got what they wanted from the organization, and this is their way of getting back their revenge. I'd also point out, which is a bit scary, your top right, you see where it says top 3 identified external sources of security incidents? The second one down, competitors. Competitors stand for a quarter of all external sources of security. Your competitors trying to hack you. So you can't believe that it's going to be a level playing field and everybody's going to be good people. People are going to try and take advantage of you, even if they are competitors in your organization. All right, I thought it was just important to touch on those 2 elements of success and security because they are relevant to our conversation. But now let's move back into maintaining information systems. So what are we going to be talking about today? We're going to be talking about obtaining maintenance requests, transforming requests into changes, designing changes, and implementing changes. So what's this obtaining maintenance requests? This formal process used by our user community to submit system change requests. We have our system in place. We need to make changes to a live system. How do we go about doing it? Transforming requests into changes, our analysis that we do to understand the scope of a change request, think about risk and feasibility that we talked about before, and then formal change designs and that implemented. Let's look at these in a little bit more detail. So maintenance process. So maintenance, these are the changes made to a system to fix or enhance its functionality, right? So this is our fifth phase of the SDLC. So we had planning, analysis, design, implementation, and now maintenance. And if I look inside the maintenance, if I want to make a change request, what do I have? The actual maintenance process, you can see in that diagram in the middle, there are 4 steps: obtain maintenance requests, transform requests into changes, design changes, and then implement changes. Okay. Does that remind you of anything? It's this very similar to the actual larger SDLC process, and that is not an accident. The concepts and techniques used to initially develop a system are also used to maintain it. And we do that because it means that people who are familiar with one, either in the maintenance will be familiar with the SDLC, or with the SDLC will become familiar with the maintenance process. It just means it's easier conceptually for us to understand how to go through the maintenance process. Okay, so obtaining a maintenance request. Do you remember this back in the day, this system service request document? This is a stage where it comes into its own. So Juanita, darling Juanita, I haven't spoken to you for a long time. Oh, it must be now coming on for 2 months. I'm getting a bit carried away here. Juanita, you see the type of request? In the old days, it's for a new system when we were going through the SDLC. But here at maintenance, we can either do a system enhancement as well, or a system error correction underneath. So a system service request can be used both for a new system or for making a change to an existing system. Okay, so we would use a system service request. What are the deliverables and outcome of the maintenance phase? Well, you're going to get a new version of the software, and you're also going to get new design documents which are going to be modified as a result of maintenance. So the deliverables and outcome of the maintenance phase are the development of a new version of software, new versions of all design documents which have been modified. There are different types of maintenance, all right? So if we're making changes to a system, we've got to think of what are the types of changes that we might want to make to our system. So there are 4 of them. Let's look at them. So we have corrective, adaptive, perfective, and preventive. Okay. Corrective, changes made to a system to repair flaws in design, coding, or implementation. So we're making some changes to correct problems that we've introduced part of our design. Adaptive, we're evolving the functionality for changing business needs or technologies. So something we didn't able to capture earlier on when we were designing and planning and analyzing the system, we now need to make changes because we've come up with something new. Perfective, changes made to a system to add new features or to improve performance. And then preventive, changes made to a system to avoid possible future problems. So we can therefore perform several types of maintenance on an information system, i.e. fixing and or enhancing it. So what do you think is the percentage of these types of maintenance out of a total of 100% between corrective, adaptive, perfective, or preventive? Well, I'll tell you right now, corrective. Corrective stands at about 70% of all different maintenance types. And the thing is with corrective, it doesn't actually add any value, not of itself, right? A corrective, remember, is repairing flaws in designing, coding, implementation. Adaptive, perfective, and preventive is where the money is. So the challenge is always, how can we reduce the amount of time we have to spend on corrective? And that's a very good question, and that's going to be something you're going to be asked for in your assignment. So we think about the cost of maintenance. The cost of maintenance. Let's look at the difference of the cost of maintenance over the years, since the 1960s up to today. If you look across the x-axis, so we're going across in time from the 1960s and 70s through to the 1980s and 90s and then 2000s to the present. And the y-scale, the y-axis, is the percentage of the software budget being spent. As you can see, if we look at new development budget for an information system has gone from about 75% back in the 60s, 70s down to about 25% now. You then look at the cost of the budget for maintenance, and it's completely reversed. Okay, so 60s and 70s maintenance was very low, and now maintenance is everything. So the problem is that more maintenance equals more maintenance work for programmers. Okay, in-house development software accounts for 52% of a company's programmers assigned to existing software maintenance. Okay, so the difference between new development versus maintenance as a percentage of the software budget over the years is quite scary, I think. It's a shame. The challenge needs to be to reduce the maintenance costs. How easy, this is a good question to ask, actually in this context, how easy is it to maintain software? Okay, well, we have this thing called maintainability, and we have the ease with which software can be understood, corrected, adapted, and enhanced is dependent on these 6 factors. So latent defects, the unknown errors after installation, and latent defects are most of the costs associated with maintaining a system. Number of customers. The higher the number of customers you have using a system, the more maintenance requests and the more conflicting maintenance requests you're going to have. If you've got one customer, You know, you're going to have less requests and no conflicting requests. If you have 500 customers, the chances are you're going to have lots of different customers asking for different things, which you can't do and keep everybody happy. So number of customers is a factor. Quality of system documentation. If you don't have very good documentation, it makes maintenance of your information system harder. The quality of your personnel, how good are your programmers? High quality programmers equals better quality maintenance. The tools, the documentation from an automation perspective and the coding tools, if you have those in place, that will facilitate maintenance as well, and the structure of your programs. Going back to the quality of the system documentation, how important do you think is having good quality system documentation? This will scare you. Our y-axis, what does it say? Percent change in maintenance effort from the norm. And our x-axis, the documentation technical quality. So if you look at where it says 400 for poor, system maintenance effort takes 400% longer with poor quality documentation. Conversely, if you look at -80 and high on the bottom right, high quality documentation leads to an 80% reduction in system maintenance effort from the norm or average. Wowza. So good quality documentation has such a fundamental positive impact on the amount of maintenance that is needed to for your maintaining your information system. Other factors we need to think about, the ongoing maintenance and support from a personnel perspective. Do we have the people who do the original designing of the code and the system? Do we have the people who write and build it? Do we have the same people supporting it once it's live? Or do we have other people doing it? Or do we have a blend of both? Well, there are three choices. You can have any of those three. You can have a separate group, different personnel to the development group supporting the system. Or you can have a combination, a hybrid model, or you can have a functional environment where the maintenance personnel is assigned to different functional units. So if you're in one functional area, you might have personnel assigned to accounting or marketing or sales or wherever. The question is, which of these is the best option? Well, as you know, in this class, there are no necessarily right answers. It depends, right? So there are advantages and disadvantages to each. The advantages of having a separate maintenance or support, as you're going to get very good improved system and documentation quality, but maybe you're not going to know about any issues that were not documented that would help you support the system once it's gone live. If you have a combined system, well, you can have a team that knows everything about the environment, but there's not going to be that much focus on the good quality documentation because you can have people there who know it already inside their heads and they're not going to write it down. From a functional perspective, well, you're going to have people who are going to be buying into it because it's going to be on a functional area. So the support team are going to be people who have a vested interest, but they're probably not going to be moving around very much. They're going to be pretty well frustrated, I suspect, at their career opportunities. You're not probably going to have the best quality technical resources available to you. The other thing to think about, and this kind of take a step back and we think about this kind of humanistically, if you like, it's more exciting to build something from new, isn't it, versus maintaining something that already exists and being built by somebody else, right? You don't want to clean up someone else's mess. It's not very sexy. You know, if I create something that does an amazing job and I take all the glory for it, and then there are problems down the line, that's somebody else's problem to fix. It's always sexier to build something new and for something to be associated with you for building it rather than just maintaining something that already exists. That's just the way of the world, right? If I think about, you know, I'm trying to think, Hoover Dam, right? Hoover Dam, you know, that's amazing to build the biggest, fastest, most amazing dam ever. I went to the Hoover Dam last year and that sprang to my mind. You think about it, they go, wow, but the people who look after the Hoover Dam today, they don't get any credit for doing so. They're just doing their jobs, right? It's not very exciting or as exciting maintaining something that already exists versus creating it in the first place. There are greater rewards, there are greater opportunities for promotion for developing something new, historically or typically speaking, rather than just supporting it. Something else in this context that we need to think about is measuring the effectiveness of our maintaining of our system. All right. So the way we measure the maintenance effectiveness is we measure the number of failures and the type of failures. Okay. So it's fundamental to understanding the quality of the development and maintenance efforts. Okay. So to measure effectiveness, you must measure the number of failures and type, and the time between each failure type of failure. And this is what we call mean time between failures. It's MTBF, a measurement of error occurrences that can be tracked over time to indicate system quality. Okay? So we understand the number of failures and the type of failures, and the average time between each failure and the type of failure therein. So we will see something hopefully like this. Okay, so after a few months of use and corrective maintenance, the average day between failure goes exponentially up, it increases. And so the number of months since system was installed, we can see that hopefully the number of days between each failure is getting greater and greater and greater because there are fewer failures occurring. Right. The last thing we need to talk about is making and controlling maintenance requests and controlling these requests as they come through. Okay. So I have a system. It's up and running. It's live. There are users using it. It might be a critical system for my environment. How do I make changes to my system in such a way that these changes don't compromise the welfare of my system that is already being used by the user community? Okay. We're going to get lots of requests coming in from different users saying, I want this change and I want that change. How can I make sure that these changes don't compromise the integrity of my system? Well, we need to control these requests because these requests can happen all the time. They can be very frequent, okay? They can be minor. They may be they may be minor, or they may be actually fixing severe defects, and they could be anything between minor and severe defects, right? So we need to think about how critical are they? We need to say, if they are critical, we need to prioritize the more critical versus the least critical. Okay, so we need to prioritize, we need to schedule, we need to have some protocol in place that allows us to assess each request in turn, that they have the necessary sign-off, and so on and so forth. Let's look at this in a little bit more detail. Here we have a change request system, and in my experience, this is absolutely the way it happens. We actually, in my bank, at Merrill's and Bank of America, we had a dedicated team whose sole job was to manage the change request system for any information system environment in my world. Okay, and that was solely their job. And every Friday morning, we'd get me on a call and we'd go through each request. It had to be raised by Wednesday, and so on and so forth. So anybody can raise a change request, okay? Is it going to be, so okay, first question, type. Is it corrective, we're fixing a problem, or is it something else? If it's corrective, let's categorize them and prioritize them and see where they go. If it's not corrective, is it an enhancement or is it adaptive perfective? If it's adaptive perfective, right, we're going to categorize and prioritize them. If it's an enhancement, is this enhancement needed? Yes. Again, we can then categorize and prioritize. If it's not needed, we can terminate request and say, sorry, not today, thank you very much. Okay. The thing about this is the categorization and the prioritization. It is could well be the case that you may have a request going in as either corrective, adaptive, perfective, or an enhancement that is needed, and it's low priority. It ain't going to get through for a long time as long as there are higher priority requests coming through the system. Okay, so low priority tasks may never actually be got to. Okay, just remember as well, perfective, this is where technical changes are put in place to increase the performance. So if that's necessary, then that's what's needed. Okay, the other thing just to touch on is configuration management. Configuration management, this process of ensuring that only authorized changes are made to the system. If I'm thinking about my software and new versions of the software that I want to release into my information system, these are some of the labels that I need to be aware of. So a baseline module, this is a baseline module. These are software modules that have been tested, documented, and approved to be included in the most recent version of a system. So the system librarian is the person for controlling the checking in and out of baseline modules. And then the build routines are the guidelines that list the instructions to construct an executable system from the baseline source code. Okay. From a configuration management tool perspective, there are two general types of configuration management tools. Revision control. This is where each system module file is frozen to a specific version level or is designated as floating, i.e. changeable. So frozen means unchangeable, or otherwise floating is changeable. And then this source code control, this is a programmer who may check out, lock, and modify a specific system module. Another kind of related question that we just need to touch on is, what about our older systems? We may have older systems that we didn't design or build or implement, but are still live. And maybe they haven't gone through the same level of process of support, enhancement, design, planning, analysis, and all the rest of it, but we still have them as part of our environment. Okay. How do we maintain older systems that have incomplete documentation, for instance? How do we support them? They haven't been built by us. They're not as good quality, but we're responsible for them. Okay. So when we have that kind of environment, we have two special purpose tools that we use to maintain such older systems, right? We can have reverse engineering tools, or we can have re-engineering tools. So design recovery tools, the benefit is they create these high-level design documents of a program by reading and analyzing its source code. Okay, so we can generate this documentation as a result of going through this. So reverse engineering tools, it reads source code as input and creates representations of design level information. And then re-engineering tools read source code as input, analyze the data and logic, and then alter an existing system to improve its quality or performance. The very last thing I just want to touch on is website maintenance issues. Some special issues and procedures apply to websites based on their special nature and operational status. These include continuous availability. How do you make changes to a system that's up and running? You may have a website that's up and running all the time, of course it is. How do you take it down? What's a good time to take it down? How do you do it so you impact the least of your user community? Broken links, hypertext markup language validation, re-registration with search engines, and so on and so forth. Checking for broken links, we've got to validate that they all still work. HTML validation, we need to make sure that the code still works. Re-registration with search engine, we've got to keep on getting visitors to our website, right? And feature additions, we don't want to confuse visitors with any changes if we have no control or limited control over our version of our website. Okay, so that concludes our maintenance.